student first of all have to make a simple design starting from planimetric and altimetric aspects of the road. The second step is a first verification of design standard, and at least the verification of the road design with territorial restriction. So after that, there is a kind of iterative process. So the student can go back into the design process and made a second phase design, changing some parameter of the road or the planimetric and altimetric aspects. So just short presentation of the structure of the lab. So what the road infrastructure that we have chosen for the lab is a two rural highway, because there's many constraints with territorial constraints in this kind of infrastructure, and can make some interesting question to the student in all of design process. So exactly in consistency with the methodology, the first part is something like informative part for the students. So they can know about some territorial analysis, like the geology, the hydrogeology, and you can see here a bullet point of all of the different info, different layer that the student can show in the first part of the lab. The second part is a design part. So there is three kind of scenario and different aspect for each scenario. So, for example, the first scenario present a high presence of environmental constraint. The second scenario represent a kind of urban bypass. And the third scenario present a complex terrain structure. So every scenario is built for made a different aspect and a different problem to the students. So how does it work? The first step of the method involves a schematic design. We can call a first phase design of the road. And so the student will refer to the information assumed about physical constraint present. So, for example, housing, crossing river, yes, and terrain detail. After that, after this schematic design, he could made a planimetric and altimetric design. So starting to choose the vertex of the arcs, for example, for the altimetric, or the radius of curve, and many other parameters. Is also included many information on transition curve and other design parameter, of course. The altimetric design. So the student can make all can choose all the parametric design also for the altimetric, not only for the planimetric aspect, and as well can choose, for example, the vertical radius and other parameter, technical parameter. So after this first phase and the verification of the the design parameter with the regulation, start a second phase design. So the student relate the road project with the environmental constraints. So in this phase, the student can, for example, made a redesign of the road by, like in this example, by changing the radius of the curve, and so making a changing of the planimetric aspect or the altimetric as well, or in other situation can choose a specific technology to make better projects, so to resolve the specific constraint. So this evaluation will be made through the application of knowledge from all other disciplines. So the last goal of the lab is related to the ability to provide students with element and idea of interdisciplinary. So a special sheet will be made consisting of different elements of matter related to road design, of course. So like geotechnicals, slope stability, or many other environmental design, for example. We have many possibility to do interdisciplinary approach with the road design. So I'm going to show you a really small video, but it's really interesting.
A continuación vamos a proyectar un vídeo desde nuestro servicio técnico.
The engineering students in the Faculty of Applied Sciences and Technologies at Marconi University have access to an interdisciplinary virtual laboratory dedicated to the spatial study and protection and to the design of road infrastructures. The laboratory, which is undergoing progressive implementations, is in line with the most modern techno-didactic models adopted by Marconi University for online academic education. The laboratory was designed and created in a multilingual version and to be used on multiple devices. Through this laboratory, it is possible to experiment and apply the knowledge acquired directly and actively from the theory lessons in engineering courses by transforming the skills and competencies learnt into typical professional practices in the design and construction of road infrastructures. The laboratory deals with highly topical issues such as the consequences of territory anthropization on the environment. It fundamentally deals with the construction and renovation of a road infrastructure and allows for a punctual analysis of the territory under several points of view. For this reason, it concerns many territorial-based subjects such as urban and spatial planning, in order to know how the works interact with spatial coordination plans. For the purpose of the practical implementation of the project, it is important to know the geology of the territory, the availability of the main aquifers, the type of vegetation, and the general impact on the environment. For road construction, it is important to take the works and structures into consideration. It is necessary to know how to resize and build the supporting walls and all the ancillary works. The foundations have priority, and for this reason, geotechnical notions are also provided. Therefore, the laboratory becomes a transversal, in-depth path compared to all the other disciplines. They all lead to the achievement of a final result. The aim is that of raising awareness towards a responsible environmental policy to prevent the negative effects linked to poor design. The core of the laboratory is the revision and redesign of a part of a street. In the simulation, an area in the south of the Lazio region in Italy has been chosen. which embraces the Rome, Latina and Frosinone provinces. In the middle of the area, the ex-Highway 609 is present, called Carpinetana, which connects the town of Colleferro with Priverno. The journey is very diverse, flat and hilly. The laboratory is structured into 3 sections. The first section is dedicated to the thematic mapping, or in other words, the mapping which is needed to understand and familiarize ourselves with the dynamics of a portion of land. It represents the preliminary study and analysis stage. The maps shown describe and deal with satellite images, the existing road network, the hydrographic, geologic and lithological elements, and the environmental constraints. The second section deals with the real and proper road design. We go further into detail and we work on enclosed territorial parts. Portions of land that need to be redesigned will be proposed. 3 scenarios are available, each of which is distinguished by particular land characteristics. The initial stretch of the road will need to be connected with the final stretch. Buildings are visible as well as areas subjected to constraints and bends. The first step is the planimetric design. In order to create the break, we will need to use the cursor and click on the different points. The vertices can also be moved by dragging. The next step involves the creation of bends. In every vertex, we will have to create a compatible bend with the appropriate traveling speed. To create a bend, it is enough to position the cursor on a vertex, and by clicking it, you will have access to the relative dialog window. The following step consists in the analysis of the longitudinal profile to study how the road is developed from an altimetric point of view. The application can elaborate a longitudinal profile of the road. The protected areas are visible and you will need to decide how to tackle these constraints. In the design, it is possible to read the amounts of each single point. On the longitudinal land profile, we should track the longitudinal profile of the road. In this stage, we must consider the slopes in order to guarantee the traveling speed safely. Once this stage is finished, you can click on the Elaborate button. The application will then create a document with the most important values. It will be possible to insert your observations in the appropriate fields. It will then be possible to send the document to the course teacher for an evaluation. At this point, it will be possible to compare other scenarios or repeat the same ones by experimenting other ways. The third section allows for access to important didactic summary fact sheets, which strengthens the laboratory theory. In other words, information on the design criteria can be consulted at any time. The educational experience that this virtual laboratory has is its strong immersive nature. The virtual environment is usable and engaging and allows for an approach to this subject that is, at the same time, interdisciplinary and non-conventional, customizable, and has great practical and applicative value.
Thank you for your attention.
Thank you very much, Valerio, for this interesting presentation.